Hello, my name is Martin. I'm very honored to attend the StarRocks first meetup in Singapore. Today, my presentation topic is the practice of StarRocks at Shopee. I comes from the Shopee Data Infra team, and I will share my presentation through the three aspects. Firstly, I will introduction about our StarRocks class deployment and management method. Secondly, I will introduce our product ecology around the StarRocks, and then I will share some use cases at the Shopee. Firstly, I will share the cluster deploy and management method. Firstly, we're using the physical machine to do the deployment. That's because of it's very easy. We only need to follow the StarRocks official documentation and step by step, and we can build our own cluster. But the problem is if we're using the physical machine, so we should share the class, multiple business should share the same cluster. If we don't share, so the resource utilization will be low. And if share, so the resource isolation is a problem. Even the StarRocks supports a very good feature which calls the resource group and can isolate the insert and select query, but the background resource cannot be isolated. So sooner we give up this method as our deployment method. We're using the Kubernetes as our deploy method. We're using Kubernetes and also using the StarRocks operator to deploy our StarRocks cluster. And advantage is very fast to delivery, and we can deploy the dedicated cluster for each business. So we can physically isolate the cluster resource between the different business projects. So we exported the cluster level resource isolation. So nowadays, this kind of deploy method and cluster manage method is our default method. And we can using the local PV to store the BE's data. But it also has some disadvantages that because of different clusters, the storage requirement is different. So the local TV may be the disk resource fragment. So our solution about to deal with this, we try to make each pod's local TV as small as it can. For example, if the user requires a 5 terabit disk resource, normally we support the 10 BE instead of 5 BE. HBE disk resource, we will local PV will give the 500 GB. So I will introduce the product ecology of the StarRocks in the Shopee. Our product ecology can be divided these parts. We have an access layer, we have ingestion channel, and cluster management layer, and StarRocks service monitor interface, and also data storage layer. Access layer is about the how to use StarRocks for the users. We currently have the dashboard. The dashboard is the user can build their own analysis dashboard based on the StarRocks data source, and also support the web client can execute the SQL in the web. And we also support the StarRocks, export the StarRocks query port to the users. So user can using the MySQL client or JDBC to access the StarRocks directly to do their business and execute the query. For the ingestion, we have 3 ingestion channels. First one is our data inference product, which called the data hub. Currently, the data hub supports the Hive to StarRocks, and we also deploy the StarRocks HDFS broker as a bucket load, and also we export the HTTP port and TCP port to the users, so user can using streaming or a Spark connector to write data into StarRocks. And for the monitor interface, currently we have 2 monitor interface. One is the Grafana dashboard, which based on the StarRocks FB and BE's metrics and information schema. And also we build our own for SQL link tracing, which can tracing each SQL's each execution stage. And for the cluster management layer, we have the audit log plugin, which can save the query log and DDL and DML, so which can be used for do some slow query analysis and audit the query log. And we also using the MySQL DB to do some account and resource management. For the data storage layer, currently we support 2 kind of StarRocks cluster. One is the StarRocks cluster, the data saved in the local SSD disk. The other one is StarRocks on Hive. And then I will introduce this kind of this layer one by one. Firstly, this is access layer, the data infra dashboard, we can see I built a very simple dashboard. This dashboard is a bar chart which statistics different users executed how many queries per day, and we can see users no need to write SQL, just to do some choose some metrics and group metrics and calculate metrics, and then can generate this bar chart. And also it supports the web client, so user can write the SQL like this one, select user counts, start from the StarRocks AudioLog DB, StarRocks AudioLog table, group by users, and get the result. And this is Data Hub. As I said, currently our Data Hub supports the have data insert to the StarRocks, so it's also called the batch ingestion. And we deploy the StarRocks HDFS brokers, and we deploy the HDFS brokers along with the StarRocks BE node together. So we can see here the black part is StarRocks brokers. And for the component cluster management, the component cluster management, we're using MySQLDB to management the StarRocks account and resource info. So it will save the StarRocks users account info and the users resource quota, like how many disk uses, how many CPU and memory they used, and based on the resource quota, we will generate the bill every month to the users. And also we save the cluster IDC regions. And the audit plugin is based on the open source project. I also put the GitHub link in the slides. So we can see here it has the query ID and username and also query status. So which is very useful to do some the query log analysis, and also help the users to analyze their slow query, and also can help us to update the tables metadata, like the tables schemas changes. And this part is monitor layer. So this is a Grafana dashboard. Our Grafana dashboard built based on the StarRocks FE and BE metrics, and also SQL query the information schema. As we can see the MV task status, and this part is we query the information schema task table. And for the RPS, QPS, and P9 latents, is we use the StarRocks metrics. And this is our full SQL tracing link. We're still doing it. It is a prototype, not released yet. In our tracing link, we can easily to identify different users, select QPS, insert QPS and DDL record, and we also can get their response error easily, and can check each SQL execution stage, execution links, which seems similar like the query profile. And I will share some of the use cases in the Shopee. First one project is DataGo. So what is DataGo project? The DataGo project is used for the data extraction. In the e-commerce company, normally they has a lot of mart table. And the mart table, when the user builds the data models, they need join the multiple tables to get the data models. And after user click, choose their filter and click to extract data, it will generate the SQL, and this SQL will be the multiple joins and join the different mart tables together to get the data. So this project, user no need to write SQL by themselves. They just choose some filter and click, and it will translate to the multiple join and get the result. As I said, the most basic scenario is multiple join, and the table model they used is OLAP model and primary key model. Here are tips about the primary key models in these users' cases. The primary key model has better query performance than unique key model, but primary key model will occupy more disk resource. And the ingestion method, the user using the HDFS block loader, because bucket block loader's ingestion performance is better than streaming loader. For example, in this black part screenshot, we can see the more than 10 terabit tape, 10 terabit spend only 2 hours and 20 minutes can finish the ingestion. And this is the query scenario, the multiple table joining. So this is an example. You can see there are 2 tables joining and with some filters. Based on this user's scenario, get the report is that the query performance is better than Presto it's better than Presto. It's about query improves 30 times. And the second project is data service. So what is data service? Data as actually is data as a service. In a big company, like in commercial company or other international company, many different teams will generate data. They will insert data to the HDFS path. They will insert data to the Hive. And a lot of the teams like backend, BI and data engineer, they need to use this data to do some analysis. Normally, people need to configure the big data components. Like they need to know how to use Presto. They need to know how to use ClickHouse. They need to know how to use StarRocks. They need to spend the time to focus on these kind of things to make they can understand how to use them and how to use them properly. The data service is a layer that can help the users to not avoid to do this kind of things, just to focus on their business. They don't need to know how to configure StarRocks in their backend service. They don't need to know how to use StarRocks properly. They just can write the SQL and based on their logic, and the data service will translate this SQL as the API endpoint. So in the backend service, just call the API can get the result what they want. So this is the overall workflow about the data service. Here is we can see I write the SQL in the SQL channel, and this SQL, after this SQL syntax check done, so it will generate the API. So call this API will translate the SQL to query the data. So the data service user scenario actually is they using StarRocks on Hive. They don't ingest the data to StarRocks itself. So the data service requires the users to write the CTE to translate their complete query as a several CTE, and they will extract the CTE to create the async material view for accelerate the query. So as we can see, the workflow looks like this. The StarRocks material view will using the Hive catalog to access Hive storage to do some of the data cache, and users API will directly query the material view. So the performance is super good. Here is their scenario. So the material view refresh method they using the manual refresh. Normally is after the Hive table is done or Hive table update is done, so they will trigger the refresh. And here is the tips about how to design the material view. As I said, normally after their table updated or after their ingestion is done, they will trigger the refresh. So trying to design the material view and the base Hive table has the same partition. So after the Hive table updated, the material view refresh is partition layer instead of they will. If you didn't design like this, the material view will full table scan, and we can see here is their report about the StarRocks on Hive and Presto. Average and elapsed time, the Presto needs almost 16 seconds, and StarRocks on Hive is 30 seconds, so 2 times. And if StarRocks on Hive using the material view speed up, is only need 2 seconds. So the first time material view creator will spend the 30 times. So the query performance is super good. Nowadays, this already becomes the OLAP speed up solution in the data service.